Hello, this is the second tutorial of a fit demonstration here. So in this tutorial, I will show you the other way to set up a TF1 function. In the previous one, I already showed you one constructor. Then let's take a look at another way to set up the TF1 here. So one of useful is to use the built-in function from the root itself. Like you already set up the Gaussian GAUS keyword and exponential, the SPO, and a polynomial. Just use POL 1 for the polynomial just to the first order, then POL 2 second order. Something similar like the following script here. So you don't need to write your function. You just put the string GAUS, and then the object like this TF1A function. Sorry, TF1A object. Now this is Gaussian, and you still need to specify the S maximum and X minimum. Sorry, S minimum and X maximum, but you don't need to specify the number of the parameters because you already given here. For example, the Gaussian has 3, so you have amplitude. The P1 will be the center, and P2 will be the sigma. Okay, and exponential term would have the P0 kind of act as how can I say, amplitude, and P1 kind of power turns, and PL2 would be the maximum would be x squared here. Okay, P2, P1 will be x linear turn here, P0 is constant turn here. Alright, so you can use again set parameters and to draw it. So this is use a built-in method, and we will show the graph later, but let me just finish very similar one. Another one is use inline, just coding the kind of formula, but you use the special character like you have bracket, square bracket, then square bracket and some number is defined by the like square bracket 0 is the first or 0 order parameter. Okay, you know the index like this. So in this case, it's similar to use the Gaussian function. So this expression is exactly the Gaussian function here, and this is the same thing as a built-in function, but I use an inline way to set it. So I will compare them. So I create a canvas. In the first canvas, I draw the function from the inline, from the user inline method into the TF1 constructor instead of the built-in function in the constructor here. Okay, and I set this curve is blue, and I draw the F2 here, compare the using the built-in method here. And then we also, this one is a fancier, we also use a method from a class. Sometimes, you have a lot of parameters and you want to manage them by a class. So you try to do something like this. You have a class, let's say this is a Gaussian class, you have a function, and this function, you have a method always return double, and with a pointer like t takes an array like some object here and parameter. Okay, so this is also the Gaussian but inside a class. Okay, so you still can access that, but it's a little bit you need to write a little bit more code here. So first you have to declare a pointer to the class Okay, this is a Gaussian class, and put the pointer in your at TF1 constructor, and then you put a function here, the simple Gaussian function for here, and you use choose a column here to this class, to column and this method's name. Also, you have to put a ampersand here, sorry, and symbol here. Again, you have S minimum, X maximum, and you have 3 parameters. This is Gaussian here. The rest will be the same. And also, I want to compare them, so I have a T canvas, and I draw the function from the class, also from F2 is from the inline, and also the first one, the default function. So let's see the result. Okay, so very cool, right? So this is the first canvas here. So we see this is the first one is the Gaussian, and this is exponential, and this is the POL, polynomial order 2 here. I said some number funny here. Okay, and then this one or that one is just a comparison with the same Gaussian function but from different TF1 constructor here. So now you know at least 3 method to call Gaussian function. Okay, and there one more thing here is to use a lambda function. Lambda function is provided by C++ 11 version, and it's called anomalous function. Sometimes it's useful when you want to combine the kind of, you have t-graph and data on the graph here, and kind of want to scale the graph a little bit. Although you can do this by other method, like you loop through the graph, but sometimes you want to fit according to another graph, to another data, another graph. Okay, so let's show you what I mean here. So the last one I want to show you is to use t-graph as a function. That means that you don't define a function, but use the data point in a t-graph to extrapolate as your function. Okay, so it's a little bit, it should be 2 steps. First, you have have your t-graph here. Then use a lambda function that can access the t-graph. So you put a lambda function into your TF. Okay, so the process will look like this. So this part is nothing but just put some data in your t-graph here. Also, remember, because you want to access the t-graph object here in your lambda function, so I tried that several times. I found you probably need to make it a global variable here. So because when you run this function here, when it's end, I think the rule do some funny thing about the memory management. So probably cannot access the t-graph gr object anymore. So it's some memory loss when I apply that. So I think the solution probably just make it to the global. And then I found it become, yes, indeed stable. Okay, so this is the way to make your lambda function. So you can also put this line, I mean this whole line before the semicolon here, to put it into here. But sometimes your lambda function is long, so you can use a variable to just kind of store retrieve it or store it in a lambda function here. Okay, so lambda function, actually I give you some syntax help. You start from the bracket, and if you put the n symbol in it, this means a lambda function can access the variable in this current scope here. So the lambda function needs still some form here. Again, it returns by a double, and also it take in a pointer, a double pointer here, sorry, and pointer with a double type here for the parameter and for the coordinates here or input here. Okay, so it's very similar. You have the TF1. This first parameter is just for the name, and this is lambda function. And then you have x minimum, s maximum, and we just have one parameter here. This is just a kind of scale factor for the data, or the data in the T-graph object gr here. Okay, so we set our function will be the 95% of original T-graph data by this line here. Okay, so let's see what would happen. So then you can see here, this line is our data from the T-graph object, and the red line is our F4 object from TF1 using the lambda function to declare it. Okay, so this is a introduction part to how other different methods to declare your TF1. I hope you can enjoy it. Thank you very much.